Satellite communications is a fast-growing industry with lots of challenges, but one company is leading the way for moving this industry forward. Find out more in today's episode.
3, 2, 1, engine full power.
Welcome to Your Space Journey, where we venture into the future of space exploration. Your journey begins now.
Thanks for joining me today for Your Space Journey. My name is Chuck, and today we're going to speak with Andreas Voight, a leader in the SatCom industry. Andreas has more than 20 years of experience in the satellite communications industry, serving as senior engineer for Eutelsat and as director of Satcoms Innovations Group, or SIG. Formed in 1997, SIG is an association that promotes innovation in the SatCom industry to improve operational efficiency and reduce impact, saving time and money. It aims to do this by encouraging industry cooperation at engineering level through meetings, events, and workshops, lobbying regulators and groups, and supporting innovation projects.
Your Space Journey.
Andreas, thank you so much for joining me today.
Yeah, thank you so much for having me. It's a pleasure to be with you today.
Well, I've been looking for this conversation, and I tell you, it's amazing. You have 25 years of amazing experience in this field, and I got a kick out of the story you shared with me earlier, how you installed your first antenna dish when you were just 16 years old. Can you tell us more about just where your passion for this field began?
Yeah, absolutely. I was in citizen band radio and was thinking about, these satellites and cable television, which was just a big show in Germany at that time coming up. That's really something I need to explore a little more. So with my bicycle and a radio, I went up to some hills looking for frequencies and whatever. And then I came along the situation of my neighbors who had a satellite dish already on their house, but they wanted to swap over to cable television. And they asked me, "Hey, Andreas, can you help me getting that dish from the roof?" And I asked just nonchalantly, "Can I have it afterwards?" And they said, "Yeah, for sure, for free. If you take it off the roof, it's yours." So, bingo, I got my first satellite dish, and due to the magazines which I have been consulting, I saw that one of the, at that time, new satellites, ECS-4, which is now known as Eutelsat 1F4, has been positioned in October, just in that month when it happened, on the 13 degrees prime position, which is now known as the hotbird position of Eutelsat, and started with some analog transmissions, 42 dB watts in KU band, so with a 1.2 meter antenna analog transmission. Yeah, if you got a spike-free picture, then it was absolutely fine. You just have to know that the LMBs at that time were something like 4.5, 4.8, 5.5 dB of noise figure in comparison to 0.2 in these days. Mm-hmm. So
what a difference.
was an interesting thing, and it hooked me for life. Yes, I agree.
See, I think you mentioned Eutelsat, because I think it's also amazing. You've got these two amazing positions right now. Eutelsat, you mentioned. Let's start with that. Can you tell us a little bit more about what Eutelsat is and your role with it?
Yeah, Eutelsat is one of the big geostationary satellite operators worldwide, next to other companies. And we are here in the middle of a telecommunication pivot at the moment. And that means that we are moving from the broadcast-dominated turnover value of what Eutelsat had over the last decades into a connectivity environment. We see that broadcast gets lower in business numbers. Connectivity is picking up because everybody would like to have a satellite internet connection or a mobile connection in closed user networks, civil, military, governmental, as you like. And that means very clearly that we need to adapt ourselves how we are working. And that's why we have developed some super powerful new satellites which are put into service, like Connect VHTS, E10B, new FlexSat for the Americas, or our Starship called Quantum, which is a completely innovative, flexible, and satellite that even has a customer cockpit. So the satellite operator is a task of designing footprints or whatever is given to the customer, because the customer can actually go ahead and design their own footprints due to their own needs. Nice. Or, as we all know, with certain restrictions in certain environments, because we're not alone in the space. But that does the software all by itself and helps our customers to go the missions. And whatever it is, it's a cruise ship in the Mediterranean, or it's a plane that flies over the ocean and would like to have follow me connectivity, all possible.
See, that's amazing. And not only that, but you also find the time, I don't know how you do it, to be the director of the Satcoms Innovation Group. Can you tell us more about just SIG in general?
Yeah, SIG is a combination out of all of the different satellite operators. That is the history of SIG. But it also contains a lot of companies who are providing software and hardware solutions for the industry, and for sure also research centers and universities or companies who would like to bring a certain value for the industry into it, and we're combining it. So that means in conferences, workshops, and the next one is, for example, going to be in the satellite show in Washington. Mm-hmm. That is, or parallel to it, let me say it like this. And that means we are going to speak about new developments. And me, being the leader of the AI working group inside Satellite Innovations Group, it is something that is very important, because here certain things that also touch Eutelsat come all together. We're talking about digitalization of our environment and service operations. Mm-hmm. And that means very clearly that we do not have the strict hierarchy anymore, where the manager is on top and does just the person environments. No, when we are having artificial intelligence and machine learning, also the manager needs to understand the technology of that religious change what we have in the control centers, in the service operation fields. Why is that? Because first of all, in the 80s and the 90s, we have been RF control centers. Then we had to add IT stuff into it for ticketing, for ETL environment, for dealing with customer portals and so on. But now with the third thing which is coming up, and that is mathematics and customer-centric behavior. That is something that is 100% clear now, something new in the environment, what we would like to have. So what do we need to understand when we use artificial intelligence and machine learning? We need to understand, first of all, the question we want to ask. Mm-hmm. We need to understand the mathematical procedure which comes after the question, with all of the manual tasks we would like to automate. And then we need to understand also the answer which is coming out of the machine processing, because it gives us, for example, in a result, 72%, it is probable that this is the solution.
Right.
So what does 72% actually mean? We are having in the control centers people who are RF engineers, who have a very good IT understanding and have also studied mathematics, physics, and so on. So that is fine. But between frequencies, between bandwidths, between handling environments, we need to understand and make them understand what these mathematical probabilities are going to be and what it actually means. And that is something like a training that I'm doing as well with our guys. And that is what I am also giving as speeches in the conferences of SIG forward in the environment, how to automatize, how to digitalize, how to go ahead and make the life for the control centers, for the satellite operators better in that particular sense.
Andreas, that is amazing. And I think it's really incredible that you're leading the AI efforts for that. And you've, obviously been in this field long enough to see these changes, from when you're 16 years old to now.
I'm just 52, it's okay.
Yeah, exactly. Not too long. What are some of the challenges, if you can say? I mean, I know there's so many of them out there, but what are the challenges that you've seen us overcome so far, that you've seen solutions put in place over these years?
Yeah, so first of all, inside Eutelsat, for sure, when you are running the CSC, our Communication Systems Control Center, then you have to deal with changes, with incidents, with problems on an everyday basis. Mm-hmm. And here it is important that you have knowledge, training, and passing information between each other, and especially due to follow the sun environments, we have to deal with several control centers that run in parallel along how the sun moves. And the documentation, the interchange between support teams, between the level 1, the level 2 environments is extremely important. And that is how we need to train and make the people understand what is actually necessary to do. In SIG, it is a little bit different for sure, because it's decoupled from the customer relationship as SIG with the different companies working together. We are talking there about technical issues that we are experiencing between each other or globally together. So, for example, if you have somebody transmitting a very strong signal, not only on one satellite, but maybe because of the antenna or the power things that are ongoing, on 3 or 4 satellites of different satellite operators, then SIG is exactly that particular safe haven where we can talk about that in the technical coordination with each other, without sharing customer information, for sure, because that is something that is important to be company secret, but to engineer a technical solution together, to coordinate between the satellite operators, and maybe even act all together. We do individual geolocations, for example, that we can find out where the interferer is coming from. And if, for example, Company 1 is having that result, is confirmed by Company 2, by Company 3, and even by Company 4 with 4 different individual measurements, and then sent to the regulatory body of the country where the emitter is coming from, then that is for sure something which is much more powerful, as if one operator is doing that by himself.
Andreas, let me ask you this. I'm just thinking as we're talking, there's, thousands of satellites going up now. There's companies putting up their own constellations. We have SpaceX, Starlink. Yes. We've got OneWeb. How has that impacted the industry as well? I know there are different frequencies, obviously, but still a lot more traffic, a lot more communications going on. How is that affecting SatCom right now?
The combination of Eutelsat and OneWeb is going to be something which is extremely important for Eutelsat and the telecommunication pivot we are going to have for the connectivity branch of our company. And for sure, in SIG, we have been having a look very carefully what kind of potential incidents can there be. Is it possible that the LEO orbit is getting very crowded, and with all of the satellites there, that we are going to have conjunction events that are seen as critical by us, conventional geo satellite operators? Is it possible that we are going to have uplink and downlink interference as the frequency ranges are shared? And here we have to say most of the LEO operators have actually done their job that they have signed while taking the license from FCC, from the local regulator where they're applying to, not to interfere geosynchronous orbit satellites. And they have implemented inhibit zones not to transmit in the direction of geostationary satellites. So therefore, that communication band is shared between us and the LEO operators. And up to now, we have not seen any interference introduced by one of the LEO operators at all. For sure, we have seen interferences between the LEO operators. That is something that needs to be discussed. But with regards to the standard satellite operators in geosynchronous orbit, that is not going to happen. Now we need to understand also how the satellite constellations are going to be flown or are organized in orbit. Here, we need to understand that you cannot fly 5,000, 10,000, 20,000, 100,000 satellites in the same way as you fly 40 satellites, as we do in Eutelsat in geosynchronous orbit. For geostationary satellites, you have one computer. It looks after it. There is an alarm. The satellite control center answers it or just acknowledges the action that needs to be done, and everything is fine. Therefore, also, as it is very far away from Earth, so it's the geostationary orbit is exactly 35,786 kilometers above the equator. Mm-hmm. So therefore, the distances we are talking about is large.
Right.
That means also that if one of these 70 or 50 meter big or wide satellites are coming close to each other, the orbital area where it is living in is something like a cube of 50, 60, 70 kilometers. And if a satellite comes close to the other one, we are measuring it in tens of kilometers. Or if it is coming 10 kilometers close, then it's already an issue. That's a completely different story for LEO operators.
Yeah.
LEO operators need to fly the satellites with artificial intelligence, with the environment that they can control the satellites and give commands and updates when they're overflying one of the gateway stations to control the satellites. And that file must be valid for the next 24 hours or something like this. Also, all of the satellites which I know of have GPS receivers on board, so they know absolutely where they are. And they know also what kind of speed they have, what kind of distance they have to others, because they can communicate to each other. So when you have a look in certain web pages or analysis and so on, it is not very uncommon that there are conjunctions events of 500 meters between LEO satellites without any question. And nothing has happened yet. Luckily, because we all know about Kessler effect and so on, like the thing which is happening in nuclear power plants of nuclear fission. So if there is one accident in the orbit, it might be game over for that level, because all of the tiny little pieces that a satellite collision produces can for sure provoke then something like a mousetrap effect that pushes the tiny little pieces further into more satellites, which explode as well, and so on. And then we have a cloud-based environment, which is debris, but not satellites. And that is for sure what the industry doesn't want. Just think about to launch satellites into geostationary orbits or to higher services like GPS or whatever kind of thing, we need to go through LEO orbits as well. And if there's a cloud of debris where we want to launch through, the possibility of having a launch failure or an impact in the launcher body is quite high then. So we better avoid that. And luckily, the operators of the LEO satellites have found a solution. And we have to trust in them. And for sure also check out all of the possibilities. One of the SIG members, which we have, is Valentin Eder from Space Analysis. He is actually having a calculation software at the moment in coordination with the European Space Agency coming up that will show us these kind of events of conjunction analysis, and not only about conjunction analysis between the satellites, but also conjunction analysis for IF purposes. So that means whenever we have same environment of a link between ground station, geostationary satellite, and a low Earth orbit satellite just passes through, then we might have an interference event. But the more we check, the less we get it. These are just non-events. Nevertheless, we better need to be safe than sorry.
Absolutely. Andreas, this is I kind of want to expound on that a little bit, sort of wrap this up with one last question into the fun part of aspects of what drew you to this field again. Picturing yourself as that 16-year-old getting your satellite dish for the first time, your hands on it. There are other people out there. I know we have listeners out there that are into ham radio or wanting to get into it just as amateurs. Do you have any advice for them to get into this field?
Well, satellite antennas to install them today, because of the powerful satellites what we have, that's not really very much difficult to do. But you need to understand certain few basics that you would like to have with. So first of all, when dealing with satellite communications, it's a quasi-optical transmission. Quasi-optical transmission means when you put a piece of paper, a building, a tree, or whatever in between the satellite and your satellite dish, you will not receive anything, or your reception will be so much impaired that the quality might be bad, or you don't see anything. So therefore, clear sky. That is the premise, what you need to do. If you're in the Northern Hemisphere, the satellites, geostationary ones, are always in the southern rim. So as the satellites are all positioned over the geostationary arc, because that is the only arc where the satellite in angle velocity has the same rotational speed as the Earth itself. That's why it stays at a one point over the equator. And that's why you need an antenna that is not motorized. You can fix it with a pole in the ground and point it to a geostationary satellite, and that's it, and you can see signals. Then for sure, some of the signals, broadcast signals, and I have been speaking about broadcast and connectivity, broadcast will always be there. Some people say, oh, broadcast will go away or whatever. No. The part of broadcast that might see a change over like pay TV systems and so on. That's 100% clear. But countries would like to have their political messages sent and their information by the president and public television communicated outside to the world. And that's why satellite is going to be surviving in broadcasting. And therefore, radio amateurs, people on the ground who would like to see something very special, they still have to rely on satellite dishes next to their internet connection, which is maybe not always available. But the satellite environment, like CONUS beams in the US, pan-European beams over Africa, Europe, the Arabian environment, Asia, Pacific, and so on, these are for sure available. And you point a dish on one of the satellites carrying these TV programs. And in most of the cases, you are able to see that in the clear, because none of these countries who would like to provide information about the country itself are going to encrypt these signals in broadcasting. So therefore, with a digital receiver that is apt for that particular region or country, here in Europe, it's mostly DVB-S and DVB-S2, or future more, if when it's going a little bit also into internet connectivity handling, DVB-S2X. In America and Asia, some of the countries have different environments, but still, they're available in the supermarket, in whatever kind of electronic platform over the internet, and you can buy that thing and install it. Then you need to understand that a frequency is normally used twice in satellite communication. That is called polarization. Mm-hmm. We have vertical and horizontal polarization if it is linear, or right-hand or left-hand circulation polarization if it is circular. And that does normally the electronic converter you have with your antenna with you. Nevertheless, when you are in linear polarization, you need to set up that particular tiny little LNB, low noise block amplifier, in that way that the two polarizations are received independently. That is something that comes on top of the peaking of the antenna to find the satellite. And then normally with the cable, pay attention, there's direct current on the cable. You need to not to produce a short when manufacturing the cables. Best is to buy one that is already in the box or something like this. Connect your receiver, which is in most of the cases even pre-programmed. You plug it into the television set and off you go.
Oh, it's fascinating advice, Andreas. For those, again, wanting to get in the field, it's so addictive. Again, it's a fascinating field. And Andreas, I just want to thank you for just all the work that you do with Eutelsat and SIG, and just want to thank you for taking time to join us today. Really do appreciate it.
Yeah, thank you very much. And to all of my ham radio friends out there, this is Foxtrot for Juliet Kilo Hotel, and 73s to all you all.
Your space journey.
Well, I really enjoyed my conversation with Andreas today, and I'm excited about the future of satellite communications. It's a fast-growing industry. If you'd like to learn more about SIG, just go to their website at satig.space. I want to thank Andreas for joining me today. I want to thank you for joining me as well. Again, if you can do me a small favor and share this episode with a friend, I'd certainly appreciate it. Thanks so much for joining me. I'll see you next time. God bless.